102, example 2.7.1. Let's solve quadratic inequalities. Now, these steps that we're going to do are going to sound very similar for all of the other inequalities that we will see in this class. So my first step is to solve it as if we just had an equal sign. So if I have x squared minus x minus 12 is greater than 0, I'm going to solve that with factoring. So numbers that multiply to negative 12 and add to negative 1 are negative 4 and positive 3. So I get positive 4 and negative 3 as my two solutions. However, my answer is not x is greater than 4 and then x is greater than negative 3. This is going to be a little bit more complicated than that. I'm going to make a number line of x values, and I'm going to put those numbers that we just got on here. I've divided this into 3 possible intervals. The interval of numbers less than negative 3, the interval of numbers between negative 3 and positive 4, and the interval of numbers greater than 4. So to see which of those intervals work, I'm going to pick a test number in each interval and see what happens. Now, you can pick any number you want in that interval, but ideally I'd like to pick an easy one. So here, the easiest number to pick is probably negative 4. You could also pick negative 5, negative 6. You could pick negative 7,000,005, but that's a lot more effort than I want to do. So let's go over here and plug in negative 4 for x into my inequality, and let's see what happens. Now, chugging that through, I get 16 plus 4 minus 12, which is 8. Now, I don't really care that it's actually 8. All I really care about is I got a positive number, which is what I was hoping to get. So I'm going to put a yes there, and then I'm going to put a yes here, because that's where I'm looking. So that's my first interval. Let's do the same to the other intervals. I need a number between negative 3 and positive 4. 0 is probably the easiest, because 0 squared minus 0 minus 12 is just negative 12, and that is definitely not greater than 0. So let's put a no there. And then finally, I need a number greater than 5, or 4. Let's pick 5. And I get 25 minus 5 is 20, minus 12 is 8, and yes, 8 is greater than 0. You can use your calculator to help you with that number crunching. So needless to say, it's the yes intervals that we want, but let's use our calculator and check this. Now, I'm not going to check the entire inequality. I've just typed in that actual quadratic, the left-hand side, x squared minus x minus 12. And let's graph that. So here, I want to know where is that greater than 0. Let me make the graph over here as well, just so that we can see that a little bit. So here's negative 3, here's negative 4. So I can see, first of all, that yes, we did cross at those values, so I can use that to check my answers. So again, here's 0. Greater than 0 means everything up here. That's where we're greater than 0. So hopefully you'll agree with me, it's greater than it over here on the left, and then over here on the right. And that is exactly what we got over here. So my answer is negative infinity, comma negative 3. Remember that little u for or we put when we have two inequalities, or two intervals, and then 4, comma infinity. I've got parentheses around that because we are strictly greater than. Now, this does not work 100%, but I can generalize in that when I have a quadratic greater than 0, then I expect to get the two outer intervals. Again, that does not always happen, but most of the time. that will happen.